sir. ಇವ್ರದ್ದು ಇಂಟರ್ನೆಟ್ ಇವ್ರು ನಮ್ಮದೇ.
Warm and pleasant good afternoon to our respected principal in his absentia, distinguished guests, ACA family members, faculty members, staff, students, and all the participants present here. On behalf of the Department of Physical Education and Sports, RV College of Engineering, and the Sports Engineering Association of India, I extend a hearty welcome to all of you to Lecture Series 3 on sports sensors to extract biomechanical responses. Today's lecture aims to provide valuable insights into the application of modern sports sensor technology in understanding and enhancing human movement and athletic performance. It's my privilege to welcome our esteemed dignitaries, Dr. K.P. Venkatesh sir. Sir, kindly occupy the seats, and Dr. Chandrasekhar B.H. Please occupy the dais. Dr. K.P. Venkatesh is a Joint Secretary of Sports Engineering Association of India and today's our distinguished resource person. Dr. KN Subramanya, Vice President of Sports Engineering Association and Principal of RV College of Engineering, I welcome him in his absentia. Now I request, it's my pleasure to introduce today's eminent speaker by Dr. Mallesh, Assistant Director of Physical Education, RV College of Engineering. I welcome Mallesh to introduce today's guest.
Thank you, sir. Dr. Venkatesh K.P. Rao is an associate professor in the Department of Mechanical Engineering at BITS Pilani campus, where he heads the Micro Nano Bioengineering Laboratory. He earned his PhD from the Center of Nanoscience of Engineering, Indian Institute of Science, Bangalore. His research experience spans micro and nano electromechanical system, biomechanics, biosensor, microfluidics, and biomedical engineering, with a strong focus on developing innovative technologies for healthcare, diagnostics, and advanced engineering application. He has successfully led several research projects funded by DRDO, SCRB, and ICMR, and has made significant contribution to microbiology and sensor technologies, mechanobiology and sensor technologies. A recipient of J.C. Bose Memorial Award, Dr. Rao has associated editor of Microsystem Technologies and is member of editorial board of BMC Biomedical Engineering. He is widely recognized for his interdisciplinary research, academic experience, and contribution, engineering and educational and innovation. Thank you.
Thank you, Dr. Mallesh. Now it's the time. Now, ladies and gentlemen, please join me in welcoming Dr. K.P. Venkatesh with a huge round of applause. Now, over to Venkatesh sir for today's lecture series on sports sensors to extract biomechanical responses.
Okay, thank you very much for the RV Engineering College Engineering for providing the opportunity over here. And myself Venkatesh from its Pilani campus. Okay, today I will be talking about, I have gone through some of your work, what has been done here. I can see that some of you are working out in the area of AI for sports and some of you are working out for sports biomechanics. And I think I saw that some of you already use the sensors over there, right? All of you might have used sensors, right? Agree? Now, let us see how exactly those sensors are made. How many of you are aware of how those sensors are made? You have used the sensors in the front end, right? You have seen the input pins, output pins, everything. Are you aware of how they are made? How they have been developed? What exactly happens inside the sensor? How many of you are aware of it? Yes, let's look into it. Let's dive into it, right? Let's see what happens inside the sensor, how we develop the sensors, and how we are going to deploy it in the sports industry as well, right? Now, and I am both with IDSPS. IDSPS is All India program where ministry, industry, and even the academia join hands together, and we are leading the semiconductor initiative over there. Now, if you look at the sports sensors under consideration to extract the biomechanical activity, here you can see the plenty of dots over there, right? Extended. Hello. Yeah, you can basically see the plenty of dots over there, right? Each one of dot over there is basically corresponds to the one of the sensors. For example, let's say you want to measure the heartbeat. Which sensor would you want to deploy over there? You would basically use, even in your smartphones also, and even in your smartwatches, you will basically measure your heartbeat, right? How exactly does it measure? What is there in the, how does it measure? We do have a inbuilt micro-machined accelerometer over there that basically measure what is your heart rate under consideration, right? Now, even if you want, let's say I am walking, I want to measure in real time, what is my angular acceleration, what is my linear acceleration. So, I can make use of, I can even make use of a complete IMU grid, which includes both accelerometers as well as the gyroscopes. Accelerometers will basically give you for the linear motion, and gyros will be gives you basically for the angular motions under consideration. Now, in this talk, we look into about all the MEMS fabrication, how they are fabricated, how we need to process the signals, and how we can fuse the sensor data to extract out the activity, and then Let's say that I want to get the real-time activity under consideration. Sometimes you may need to go ahead with the wearable electronics, or sometimes nowadays we are not wearing the electronics. Nowadays it's the time to swallow the electronics. That's where the next generation of the electronics comes up. That's a edible electronics under consideration. So what's the basic motivation behind it? The basic motto is to extract out the biomechanical response. Why the biomechanical response is important? Why the biomechanical response is important? Because this biomechanical response, even if you take up any sportsman, the biomechanics of sportsman plays a very, very critical role in his performance, right? So in the performance characteristics, the biomechanical responses plays a very, very critical role. So as to extract out the biomechanical response, here we are basically making use of the sports sensors. Basically, we make use of micro and nano sensors. In this case, we are basically making use of if you want to do the continuous monitoring, you can go ahead with the wearable sensors. And even if you want to go ahead with any of the, even you get the sensors in the macro scale and milli scale, and even with the micro scale, we do like to go with micro and nano sensors. Why is it so? Because they are accurate and they are cost effective. Right now, if you look at the industrial revolution, what has been happened? We do have first generation, second generation, third generation, and fourth generation as well. Now, in the 20th century, all the industrialization happened. That's where the second generation of the second industrial revolution happened. The third industrial revolution, it's basically a new financial model has happened. Now, what's happening in the present industrial revolution? The cyber physical system, IoT, and AI. All of you know that AI is booming now, right? What is basically there in the back end of the AI? It's basically the sensors, right? Sensors is basically the back end. So sensors plays a very, very critical role in the present generation under consideration. So if you take up the technology evolution under consideration, we have the several sectors ranging all the way from the textile industry to the biomedical sectors. Now, see this between the yesterday's generation and today's generation and tomorrow what it would be. Right? You can see the change. So what changes you can see between all three of them? Unitake, please. Unitake. What changes you can see in the, if you look at it from the yesterday's generation to the today's generation and the present generation, these are the three driving parameters for any of the technology evolution: accuracy, cost, and time. So it should be accurate, it should be cost effective, and it should be time efficient, right? That's what we basically call it as act now for the betterment of tomorrow. So how do we do that? So basically act in the present R&D is basically the accurate, precise, whether it could be a dengue detection or a malaria detection, or even in this case of a sports activity as well. And it should be affordable, right? And it should be ultra fast. So what is the answer for all three of them? So micro and nanotechnology is proven to be the answer. So whenever you take up any of this, right, if you want to cater for all three of them, the micro and nanotechnology has been proven to be the answer for this. So if you take up how to get a feel of what is a micron, for example, if you take up a single cell in our human body, it will be typically around tens of micrometer, and if you take up a human hair, the diameter of the human hair will be typically around few hundreds of micrometer, depending upon which shampoo you use, or diameter of the human hair will further change. And also, even if you look at the tennis balls, typically the tennis balls will be in a few hundreds of millimeters under consideration. So this is how you can see from the macro scale to the micro scale to even to nano and to the single atomic level as well. We can design the sensors at several resolutions. So let's say that macro levels is like the entire human body, and on the other hand, if you want to look at it around a single DNA molecule, those things will come under a nano scale. On the other hand, even you can even look at the molecular motors, those things, they'll basically come under the intermolecules and atomic level resolutions under consideration. Whatsoever you can see at the bottom, this is basically a single chip of the sensor, and here basically I opened up the chip. So this is like a mesoscale, and these are micro scale, and these are atomic level resolutions under consideration. So why do we basically go ahead with the micro and nano scale devices? Because they are small, right? They are small. They will occupy very less space, and at the same time, the mass of those products will be extremely small. Why the mass has to be small? The mass has to be small because it should not add up additional mass to our human body as such, right? And for whenever you are going to measure it, and also the power requirement is extremely small. It's in the range of a few milliwatts. That's why this micro nano systems plays a very, very important role in extracting out the sports activity under consideration. So you can see the two of them on the left and right. Right? What difference you can basically see between the left side and right side? So on the left side is basically the natural system, right? This is where you can see the ATP motors, the insects and all those things. And these are all the man-made, the synthesized systems, what has been man-made, right? We can basically see the scale, which basically tells about ranging all the way from the macro scales to micro scale. So if you take up the miniaturization, so it started in 1960s. That's where your bulk silicon came into picture, and then the MEMS technology has started in 1990s. And then we went ahead. Now we are in the going ahead at the 2030s. What we are looking into towards the single molecule direction as well. So if you look at the micro nano scales devices, right? Even we do have the IMU chips. I saw that majority of you are already using the IMUs for your projects, right? So whenever you want to develop those sensors, you'll basically have the several fabrication process like the photolithography, and we need to just like how you do the building, wherein you first deposit and you etch away, right? Similarly, you will do again in this process also, you will do the deposition and the etching process to get your structures. Either you can make it like a chip and you can package, or you can even make it like a wearable systems as well. Now, some of you might have worked out on the wearable electronics also. You can even well make it like a wearable electronics, and everything you can embed into the silk as well. Where if you wear it, then you will extract out the entire physiological activity of the human being. So what are the benefits of the micro scale you will get? The first and the fundamental thing is that it will basically take up very less power, and since it is miniaturized, so it will be ultra fast under consideration, and the sensitivity of these miniaturized devices will be much more than your macro counterparts. And since we are going forward for batch fabrication, the cost per product will come down quite drastically, right? That's what's the last one you can see over there. So if you look at what are the different sensors which we usually use in the sports activity, so majority of you have used the IMU, right? That's what I have basically written over there, the 6 degree of freedom for measuring which includes both accelerometers, gyros. So are the multi-axis sensing. And why do we basically make use of the MEMS sensors over here? Because they will basically require low power. So some of you have seen that we are basically using the power circuit to power up the ASICs and all those things. So it's not actually required in majority of the cases. Whenever we are walking, we do have plenty of biomechanical activity. When the biomechanical activity is there, then the stresses gets generated, correct? When the stresses gets generated, you can even well harvest that energy. With that energy itself, you can power the electronics. So that's the beauty of your MEMS and nanoscale devices under consideration. On the other hand, if you take up surface area to volume ratio, if you take up a sphere, right, you can see that surface area is what? 4 pi r square, and volume is 4 by 3 pi r cube. If you take surface area to volume ratio, you can see that it will basically scale as 1 over r. That means what? If I go from macro scale to the micro scale, the surface area to volume ratio will increase, correct? So what does surface area to volume ratio increases means? Which means to say, the surface effects will overtake the volumetric effects, right? So whenever you go to the macro counterparts, then, for example, you take up a fine ground salt and you take up a rock salt. Which one will dissolve quickly? Whether fine ground or rock salt? Fine ground, right? That's what, right? Because fine ground salt, the diameter of the salt will be extremely small. So you do get very quick chemical activity in case of the fine ground salt as well, right? And also if you take up even the dust also, right? If it's a fine dust, that will be much more explosive. On the other hand, if it's a coarse dust. So this miniaturization has come up from the talk by Richard Feynman, who is a professor at Caltech. That's where your microsystems and then nanotechnology came into picture. So what does this MEMS basically stand for? MEMS basically stands for micro electromechanical systems, which is basically having the microfabricated structures, and then it has the electrical activity. Either it could be electrical input, mechanical output, or the mechanical input, electrical output. We can even develop the systems out of it. So that's how this micro electromechanical systems came into picture. That's how the name micro electromechanical systems. These MEMS devices are indeed placed. These MEMS devices can be basically classified into sensors as well as actuators, depending upon either you are sensing it or you are using it for the actuation purpose. There are several transduction principles with which you can, as I mentioned, you can even self-power the systems using the energy harvesting. Here, you can see that these are all the sports persons. We are even deploying the sensors at different locations to extract out the biomechanical activity over here. In the coming slides, I will show you how we are going to use these sensors to extract out the biomechanical activity. So, some of the sports sensors you would basically require is, let's say that if you want to embed it in the textile, then you can go ahead with the wearable electronics. That's where the wearable sensors. And then some of you have already used the IMUs, which basically has the inertial sensors like the accelerometers and the gyros. And also, let's say that in the real time, I want to measure the foot pressure. So let's say that I want to make up a smart shoes, right? Smart shoe, wherein I can even develop a smart insoles. I can make up the complete insoles with a piezoelectric materials that can even well measure one, or you can even embed the load cells into your insoles that can measure the real-time gait, even it can measure the pressure monitoring as well. And we can even well develop the several biomedical devices that will tell us about what is the muscular strength, and also the bone health. Plenty of things can be done with the help of micro and nano systems under consideration. As I mentioned, whenever you want to fabricate these micro and nano devices, we have to go ahead with the three processes. First is a deposit, pattern, and etch, right? Just like how you are building your house, here also we are basically first you are going to deposit the thing and you pattern it, the shape what you want, and you take away the unwanted material out from it. That's basically the etching process. So these are all some of the commercially available sensors for sports activity, which are the accelerometers. Accelerometers will tell us about the linear accelerations, which will be quite useful for measuring the gait activity. And even when you are using it in the wearable electronics, you can even well track the activity of your hand activity, foot activity. Plenty of things can be done with the help of accelerometers. As accelerometers will measure the linear acceleration. On the other hand, if you want to measure the angular acceleration, then we will be going ahead with the gyroscopes. And then if you want to measure the pressure, because you know that the pressure, the foot pressure indeed will tell us about your health activity. And also, let's say in case of sports also, if you are applying so pressure, if you are doing the bowling, he has to come at so speed, and he has to basically throw at so speed as well. In plenty of those applications, you do require these gyros under consideration, right? And for the pressure sensors, which we basically use it for the insoles to extract out the foot pressure monitoring. And the strain gauges will be quite handy whenever you want to, or let's say you want to basically look forward for the load cells which will be embedded in the if you walk it on any track and within the track you can embed the load cells, that will basically will tell you about the gate activity rather than using high-end equipments like the high-speed cameras, which will cost you around 20 crores, 30 crores. No need to go ahead with the high-speed cameras. We can even make use of the strain gauges, and we can make use of IMUs to extract out the entire activity. So these are all some of the MEMS features. So it can be either electrical input, mechanical output, or the mechanical input, electrical output. That's why we basically call them as the electromechanical elements, right? And these dimensions are typically, the single component will be in few hundreds of micrometer. On the other hand, it's the entire device, once you package it, that will comes out in 22,000 micrometers under consideration. It's not just in the sports activity, it has plenty of applications in the automotive sectors. Even within your mobile also, there are plenty of sensors under consideration. That's how we are basically measures. Even if you look at the consumer domains, wherein you basically have the sports training devices, right? The plenty of sports training devices, they basically have the micro and nanoscale devices, sensors for measuring the activities under consideration. So these are all some of the commercially available applications. Even the inkjet printers, whatsoever you use in the day-to-day life, they do made out of micro and nanoscale devices. Even our it basically, if you look at a projector is also made out of the basically the digital displays, right? Nowadays, it is basically having the micro mirrors, and nowadays we are coming out with disposable medical devices as well. In the earlier days, when you used to measure our blood pressure, or you want to measure the blood glucose level, we have to go to the hospitals, right? Nowadays, we are not going to hospital. We basically have even the lab on chip devices, which does the job as well. Now we have even well designed with the patch show that one single sensor can measure the 25 properties of your human blood, right? So that's the beauty of our technology revolution under consideration. So you have all of you are carrying your smartphone, right? You look at within your smartphone, there are plenty of sensors out there, starting all the way from the micro mirrors to the IMU unit, and even the SAW and BAW filters, and even the microphones as well. There are plenty of MEMS and NEMS sensors which are over there. You can't place a convention. Even the front cameras, all of them are basically having your micro and nanoscale devices. Even if you are going in a car, you are basically has a airbag deployment. What is there in the airbag deployment? The heart of that airbag deployment is this analog devices accelerometer, right? So this analog devices accelerometer will basically measure how much is the acceleration which is coming up, that will deploy the airbag at the required time, right? So that's another. So if you look at the evolution of the sensors, it has started all the way from the strain gauges and went ahead to the inertial sensors and the microphones. Whenever you look at the sensor activity, there are basically three components in the MEMS, which is basically the actuators, sensors, and the microelectronics. So all of you have used the IMU units, right? So let's see what exactly is there in it. So it has just here the three activities, the three vertical components: actuators, sensors, and microelectronics. The microsensors are like how we have the 6 sensors. This is basically the arms, eyes, and nose. They basically continuously gather the data. Data can be in the several form, and they basically gather the data and pass it on to the microelectronics. And this microelectronics will basically smartly play with the data. They are like the brain of these MEMS devices. They play smartly with the data. They receive the data, process the data, and then it takes the decision and it will send it to your actuator. The actuator is basically like a trigger switch that will actuate the external device, and that will basically move the mechanical activity for your structure. So on the other hand, there are several horizontal components as well. So whenever you have something in your mind, let's say you want to extract out the sports activity, so you have to design your sensor accordingly. The first and the fundamental phase is the design phase. And then next is that once the design is ready, you need to keep in mind the fabrication constraints during the design phase. And then after the fabrication is done, then we need to see that whether the fabricated devices are meeting my expectation or not. That is where the characterization phase comes into picture. After the characterization comes the final phase, that is the packaging phase. Usually the packaging takes around 90 to 95% of the cost for the sensor development. That's why this characterization plays a very, very critical role before going to the packaging. So if you go to the MEMS in the sports, so we would require the micro and nano devices, whether if you want to make up a normal shoe into a smart shoe, right? When there as well, you want to extract out the gate activity. We do deploy several load cells inside it, or you can make up the complete insole with the help of piezoelectric materials. You can extract out the gate activity, and let's say that you can even well develop the smart helmets also, which can extract out how much is the force which has been impacted on it. And also while swimming, you can design a smart suit. The smart suit can even has the sensors embedded in it, which will extract out how much is the stroke and also how much is the joint movement. So which will be further useful for the training activity also, and even in the cricket also, right? Within the bat, we can even well deploy the several sensors inside the bat. It will basically measure how much is the rotation and how much is the force with which you are basically hitting it. And even inside your ball also, you can even well now in the Australia, what they are doing is that when I been meeting with RMIT, they are basically opening out the entire ball, and inside the ball, basically they are deploying the complete IMU unit. The IMU unit will basically measure what is the angular acceleration, linear acceleration, everything it will measure it in. So if you look at the complete process value chain for any of the MEMS thing under consideration, we start all the way from the design, then we fabricate it, then we get it out like a 6-inch wafer, then we will singulate each one of them. That's what you can see this, just like a dicing. And then after dicing, we will attach it to a substrate, and then we will wire bond it. That's what you can see, the wire bonds. So if you open up the IMU unit, whatsoever you have, right? So each IMU unit would look something like this, right? Therein now whenever you are using, you might have just seen the input pin and output pin and the power pin, right? But what is there inside it is this. Is the single wafer which is indeed put up on a substrate, and that has been attached to a substrate, and later on it has we do the wire bonding between the mechanical structure and the active electronics, which is ASIC. So if you look at the anatomy of any package under consideration, it has basically the MEMS device. This is a case of a microphone, right? Whenever there is acoustic waves which are coming up, that will lead to the vibration of the diaphragm. This vibration of the diaphragm gives you the capacitance change that we will be connecting it to the ASIC. ASIC will basically convert the capacitance change to the voltage output. So there's we have the ASIC and then the sensor. They are integrated, connected each other with the help of the wire bonding. That we are basically all the ASIC and the substrate, ASIC and the sensor are placed on the same substrate. That is this substrate. And we are basically taking out the connection from the ASIC to the sensor using the wire bonding. So there are several types of these microphones as well. Either you can have the opening from the top or from the side. There are plenty of ways. Whether you want to measure it from which way, then you can design it accordingly. So whenever you go ahead with the MEMS packaging, you need to keep in mind where exactly you want to deploy it, right? So depending upon the application, we have to design the ASIC as well as the package accordingly, right? So while designing the package, you need to keep in mind that your sensor should not be, whenever, let's say, if you are using it for the sports activity and the person will do the huge amount of flexion or an extension, that may even lead to the damage of your sensor as well, right? So that should not happen. That's where your packaging plays a very, very critical role. So we need to keep in mind the protection of your sensor from the external environmental conditions. And also we do have, in case of MEMS devices, not just the electrical counterparts, we do have the mechanical moving parts along with it. So it becomes completely a multi-physics environment under consideration. And also, as you saw in the previous slide, we have the MEMS device and we have an ASIC. Both of them are put up on the same substrate. So you might be aware of the coefficient of thermal expansion for any of the material. So both the substrate has some coefficient of thermal expansion and your device has different coefficient of thermal expansion, and because of that, it will basically would lead to the thermal management plays a very, very critical role over there. So these are some of the packaging factors. First one is the thermal management, where let's say that if there is a heating or cooling of the devices, then that will lead to stresses inside it. And in case of MEMS devices, we do have a moving mechanical parts. Since we do have moving mechanical parts, unlike the ICs, we don't have moving. These are 2D planar structures. In case of MEMS on sensors, we do have the mechanical moving parts. So these moving parts have to be taken into account. That will lead to the stresses and strains inside this. And then whenever you are using it in the external environmental conditions, let's say if you are using it in a defense application or in a sports application, so these external environmental factors plays a very, very critical role. As I mentioned, in case of thermal management, you need to look into that whenever there is a CTE mismatch between the both substrate and the sensor, that will lead to residual stresses. Then how you are going to take away the heat from your sensor is what for which you need to even look at it from the FEA simulations. There are plenty of things you can do out here. And even for the, since it has a moving mechanical parts, right? So first one is the whenever it takes up the whenever the vibration is there, if the input vibration becomes close to the resonant frequency, then it will lead to catastrophic failure of the devices. So this vibration also plays a very, very critical role. And in majority of the MEMS devices, we need to even go ahead with the vacuum packaging. Since majority of you have already used the gyros are basically a resonant sensors. In case of any resonant sensors, the vacuum packaging plays a very, very critical role. And also, as I mentioned, whenever there is a thermal mismatch between the two, then because of CTE mismatch, it will further lead to the failure of the devices. Whenever that's why the appropriate selection of the interfacial layer plays a critical role in this sensor development. And then whenever there are external environmental factors, for example, you are using it on the human body, right? That's what you basically do in case of sports. On the other hand, you need to even look at it in case of the majority of the naval applications. In case of naval applications, the sensors indeed go inside the sea. Then whenever you are using in a human body, and also when you are doing the swimming activity, then we need to keep in mind you need to keep the electronics dry. Right now, if you take up the process value chain of any MEMS devices under consideration, this starts all the way from the design, fabrication, dicing, and then this. So take up a simple example of the micro machined accelerometer, right? The majority of you have used the MEMS accelerometer, but what happens in the back end of the MEMS accelerometer is this. So it has basically a proof mass suspended with the help of set of beams. When there is an input acceleration coming up, this is basically we have the top plate and bottom plate. So that will basically lead to the capacitance change. That is as I showed you earlier. So we have the capacitance change has to be converted into the voltage output using the ASIC. So there are plenty of applications for this, ranging all the way from the consumer electronics to the sports activity as well. So depending upon the application, you have to choose the transduction principle accordingly. So in case of sports activity, since you are going forward with a larger acceleration, so it's always recommended to go ahead with the piezoresistive devices, right? These are some of the MEMS sensors we are using it in case of the sports activity. For example, we are making use of the IMUs, so these are basically a gyro campus to extract out the angular and the linear acceleration. So just like instead of making use of high-speed cameras, which is around 20 to 30 crores, you can make use of MEMS and NEMS sensors to extract out the biomechanical response of it. So that will give you the complete motion analysis, and also you can even well measure the bone health, muscle health with the help of the wearable electronics, and then the MEMS and NEMS sensors under consideration. So in the real time, you can extract out the activity of our human body, and also it will even, let's say that the coach has to train the individual accordingly. So you can keep on, you can have the continuous monitoring of the individual, and the coach will get in a real-time data of how he is performing. So his performance optimization is another one, which will basically useful with the help of MEMS and NEMS sensors. So these are some of the accelerometers and gyros which are basically used for the gait activities, wherein we have the swing phase and the stance phase. So again, instead of using the high-speed cameras, we can make use of the MEMS accelerometers over here to extract out the swing phase and the stance phase, right? And then at the same time, we want to extract out the foot pressure levels. We can even well deploy the pressure sensors to extract out the foot pressure monitoring. So you know that foot pressure monitoring is not just in the sports activity, even in the biomedical sectors, that will even tell us about how good is our, what is our foot pressure will basically tell us when you take the diabetic health, right? If you look at the diabetic monitoring, the foot pressure will also tell us about how good is the health condition under consideration. There are even plenty of IMU sensors which are already used, even for the swimming and other things. We can extract out the pitch, roll, and yaw, and then with the help of gyros, we extract out pitch, roll, and yaw, and with the help of linear accelerations, we can extract out with the help of the accelerometers, and then we can make use for it even for flexion, extension, and then for the fatigue as well, right? The future trends are indeed, now we are making use of smart textiles. Now what is expected the next by 2030s is making use of implantable MEMS. So these are some of the applications. We can make use of pressure sensors. So how the pressure sensor works. So this is a single pressure sensor, how it looks, right? So inside the pressure sensor, if you open up, this basically has a sensor and it has an acid. This is a piezoresistive based pressure sensor. Indeed, in majority of the sports applications, we make use of the piezoresistive based pressure sensor. Whenever there is a deflection, that leads to resistance change because of the stresses which gets generated. Now, when there are stresses, then we get the resistance change. Resistance change will be transformed into the voltage output. You can see that we get a voltage output when there is a resistance change. That's again because of the Wheatstone bridge configuration. And then this is a case of an accelerometer, right? In case of an accelerometer, this is you can use it in the airbag deployment, and I already told you about the plenty of applications in the sports as well. So in majority of the vehicle, right, in the airbag deployment, I showed you, right? You can in the real time you can see the air, and even in your mobile phones, you do have the both accelerometers and gyros which are basically deployed. And if you open it up, then you basically see a set of poom fingers which are over there. When there is an input acceleration coming up, then you can see that there is a capacitance change. See this? When there is input acceleration coming up, that leads to deflection, then we get a capacitance change. This capacitance change, now it will be converted into the voltage output through the ASIC. And these are the gyros which we will be using it for measuring the angular acceleration. And same thing you can use it for measuring the biological activity, right? Even this is basically a smart
as I mentioned, right now it keeps on giving us the acoustic signals, and can even well extract out your heart activity with the help of it. These are some of the gyros which we ourselves have developed for the Indian Navy. We can do the detailed analysis. I'll skip these slides as the interest of time. Here we can basically see that these are the fabricated devices. We singulate them out, and then we can develop the entire system. If you look at the single gyro, each gyro would look like this, right? Which will measure all three of them with a single device. Instead of mounting 3 sensors, we can have a single sensor which can do the job. And we can even well develop with the help of optical device and with the piezoelectric systems, right? And we can do the detailed system level system level analysis. We can even well have the ASIC, and here is a complete IMU unit what we have developed, which is there on this. Whenever it moves, it gives you pitch, roll, and yaw. And this is a case of a just an this is a case with a complete IMU unit, and this is a case with a simple gyroscope under consideration. So once this moves in real time, I can extract out pitch, roll, and yaw. And we can even well use it in the several applications. For example, let's say any of the sports person will feel sick, then in the real time you can extract out the biomedical activity of the individual. You can just put it like a patch that can extract out the biomedical activity, both the skin health, bone health, the muscle health. Plenty of things can be extracted out with the help of these sensors. These can be extracted out, even you can look at it at the cellular level or even at the tissue level. Plenty of things can be done with the help of this micro and nano systems. Okay, and I was telling you the last one, that is on the nowadays, it is a time not just to keep the electronics on your hand, it is a time to swallow the electronics. That is where the edible electronic comes into picture. Within the edible electronics comes the edible sensors. So in the edible sensors, we have basically developed in the natural system also, there are plenty of piezoelectric materials which are there. Take up the food waste and you convert that food waste into a sensor, and we can even develop a piezoelectric material which you can swallow inside, that will measure in real time what exactly is happening inside our human body, right? So what we want is, rather than having just lab on chip, we want to have completely hospital on chip. It will measure the real time activity and it will repair things instantaneously. So future scope is completely on this, which basically the edible electronics and the edible sensors. So I'd like to thank my team and of course the RV College of Engineering for giving the opportunity. Thank you very much.
Yes, sir. Thank you very much, Dr. K.P. Venkatesh, sir, for your highly informative and thought-provoking lecture. Your valuable insights into sports sensor technology and biomechanical analysis have certainly enriched our students and understanding and inspired us to explore this exciting field further. Now it's the time to welcome our beloved principal, sir, on behalf of Department of Physical Education and Sports. I welcome you for this lecture series, sir. Now,
Okay, namaste. Namaste to all of you. So I had just kept this slide, that's all. And I may tell some important things. I think Venkatesh, I was listening while I went to Kantirva Stadium to receive an award for the college. So while coming, actually, I was listening online also, whatever he was telling. Let me give some general information to all of you. Let me start from a case study that there were 3 students in our college. One student was called Tejas. He was an industrial engineering student. And these are all the 3 I'm talking about are all national, international players in sports. Okay. So this Tejas, when he was in final year, he already had a training center in the ring road. He was a shooter actually, 10-meter shooter, and 12th was his Indian ranking. Fine. And he was already teaching the children about the training, how to do shooting. And he called me once to his training center here, and I went there. And let me tell you the kind of technology which was there, we were not aware. Because in our country, sports is still a secondary or a hobby kind of a thing. I don't think 99% of the people take it as a profession. I want to become an engineer, I want to become a cricket player. I think it's like that. Fine. Whereas in other countries, so in developed countries, they take it as a profession, and you have a lot of degrees in sports itself, which is available. Slowly in India, now it is coming up. It may take another 5 to 1 decade. Many private universities have started that sports engineering itself as a degree. So when that is going to come, I'm sure that in India also that situation may come. I'm sure many of you may be sports players here, or you may not be, or just to make one credit easier, you might have joined. I don't know what all the reasons for which you have joined. Okay, but the kind of technology which is there in sports and entertainment industry today, I don't think it's not even there in manufacturing sector. I think that's the way the sports is there. So the student came and I went to his office, and he was training, and he puts a camera and then he'll be doing shooting. In shooting, the biggest problem is not just shooting alone. The mind, body and the soul, the kind of concentration and the perfection you should have should be more than 100% actually. So in Olympics and all, what they have done is now, before they used to have a cage where the sound was not there, but in Olympics they have taken out those glasses now. There will be noise also from the crowd, which was not there before. So obviously when noise is there, again you are going to find problem. So he was telling me that up to 1970-75, he was wearing the camera in the head to watch his movements, how it happens, and then perfectly matches and hits. So he was telling that up to 1970-75, this camera itself was not there in India. All these things were won by Russians only generally. After that, it came to the world, and it is a perfect in industrial, we call it as ergonomics or human factors engineering. So ergonomics means a man-machine interface, or it could be between a computer and a human being, a car, a cockpit versus a human being. All these are called as a man-machine system interfaces. So if there is no perfection in that, then you're going to face problem. So it was typically a cognitive ergonomics. Perfectly the mind tuning has to happen. So then he came, he was in final year. He told, I went to his team. I told, if you are interested, you can do project in this only for your 8th semester. Okay. So I made sure that it is tuned to industrial engineering. Anyway, cognitive ergonomics is industrial engineering. And I tuned to that and he did the project. He started the project. Then one more person came. So his name is Arvind. Arvind Avinash from aerospace engineering. Fine. So what happens in our departments generally is, if you take any kind of a project like this, no, your department will not appreciate it actually. They say, what is mechanical in this? What is electronics in this? That's the way our whole teaching profession happens. But today there is a thin line between branches and everything is interdisciplinary in nature. So this student came and, sir, you are guiding Tejas. By the by, Tejas is a civil servant now. He's an IAS officer. Okay. So he did, and he's doing very well. I think he completed his training also, and he's been posted somewhere. So they are such a perfect people. So why I'm giving all these examples is, you may have taken just for one credit, but this may become a profession for you. So that's why at least some 5 to 10 who are interested here can take it as a profession, because the highest money paid today in the world for an youngster He is a data analyst for National Basketball Association USA. He is the highest paid youngster in the world. The kind of analytics he does for all the players in the NBA teams is enormous. So if you're just looking at AI software, so these salaries are much higher actually. A physiotherapist, a commentator, or your bowling coach, fielding coach, whoever it may be, they're all minting a lot of money. In fact, Gavaskar has made 10 times the money after he retired than when he was a player. So if people are looking at only money, I feel entertainment and sports has the highest money. But I think you don't even perceive that because we are all stuck within the box. Nobody thinks beyond the box. We had one person from our electrical statistician, Gopal Krishna. Anybody has heard the name Gopal Krishna? So he was an electrical engineer and he was the statistician for Karnataka Cricket Association. He's around 80 or 82 now. He was a statistician for Karnataka Cricket Association for more than 50 years. I think if possible, you call him once. The kind of questions he asks, even cricket players cannot answer. Those who have played. Beautiful quizzes and all he conducts. He took it as a profession directly, as a study, because during those times, he used to write in the books actually. There were no computers and things of that sort. With that, he has so much of analysis of the world cricket he has done. And if somebody is interested in cricket here, if somebody wants to take up research in cricket, you should go to MCG. I have visited there. MCG, Melbourne Cricket Club, has got a beautiful cricket research library. Started from cricket till today, everything is available there. Anybody would like to do research, you can do it. In fact, by the way, MCG is just a stadium, correct? But it's a half a day trip. They show it to us. The kind of technology they have, the kind of things they have is enormous there. So then this Avinash came, who was a aerospace engineer, and Avinash and Arvind, the two brothers. One studied civil, other studied aerospace. And these two represented swimming in the Asian Games. They stood 6th and 7th in the country. So this fellow came aerospace. He told, sir, Tejas is doing, I also want to do project under you. So he came separately. So then swimming, aerospace, how to link? So I was not knowing. So I was just asking him, tell me what is most important in swimming. Okay. And why Pelp gets so much of gold medals in Olympic swimming. He told that the first jump you take, no, from here, in fact, Pelp has too much of this leg space here. Length is very high. He says the first swing, whatever I do, so that is the most important for winning a gold medal. The difference between gold and silver is that only he was telling. So then I told, if you want to swim like this, you jump like this, it is typically aerodynamics, correct? So you can link always anything to anything on this earth. So I told him, you take this particular portion and do the aerodynamic study and see whether you can improve your swimming things points or not. That's what the catch we took it. And you know, until that time he was not knowing, to do all these studies, India doesn't have a software. Whereas the Olympian swimmer uses a software for all these things. He came to know, I allowed these people, you can interview anybody in the earth, it doesn't matter. So he caught up one Olympian who was a swimmer, who has got a gold medal in Olympics. And he interviewed him and came to know a lot of things which was not known to Indians at all. So then I allowed him. So he did that project. He did beautifully, learned the software, and then put all the things. And after that, he also used it for his swimming exercise also. And he tried to improve his timings also. Fine. Then after seeing these two, one more person from mechanical, Shreyas Kulkarni. So Shreyas Kulkarni came. And Shreyas Kulkarni, his ranking is around 31 in the table tennis in the country. He's a mechanical student. He told, sir, I also want to join this group. So then I took, okay, you come. I asked him, okay, when you are hitting the ball from the bat, so what is that position? If you hit, your opponent cannot hit that ball. So they're all very smart children already because they're all representing the country. So they know what is what. But only thing is, it becomes, we have to catch all these points, that's all. Okay. So then he told, then I told you find out this point and see how many times out of 100 you're hitting from that particular point. So we designed a sensor for that and tried to make a count of it. So like this, we took 8th semester project. if I send them to the department, I think people will not appreciate. So I do a lot of such innovations, which you may not know. Fine. So I told these people, okay, come all the three of you in one batch. I told all the HODs, okay, I'll be the guide, don't worry, I'll take care of these things. And then they did a good project, and I put productivity studies in sports and games as the title. Case study 1, 2, 3, I put it, and they submitted a report also after doing all the work. Okay, and everybody got a good grade also. And all these 3 papers were separately published in the sports journal. One was published in the London sports journal actually. And out of all these 3, I think one person pursued his study. He completed master degree also, Tejas. I mean, Tejas is a Shreyas did his master's degree actually. And now he's working in Australia now. Yeah, he's in Australia now. And one was a civil servant, and other I don't know, or even where he is, Yeah, so I think he also completed his master's. So why I'm giving this example is, this is the kind of opportunity in RBC you have. Anybody has got any kind of such interest, you can come back to me directly. I'm going to help you, and see that connecting the dots is very easy, because today everything is interdisciplinary in nature. I'm sure people sitting here, if there are mechanical students are there, whole lot of sensors, whatever is explained, is there in almost all your cyber physical systems. You take a Mercedes-Benz car, the kind of sensors you have today is enormous. So it's only that you should find out. We are very bad generally in the systems way of thinking actually. We think very narrowly. Okay, this is mechanical, this is design, under that is a bearing design, and then you get stuck here, and you don't see the whole part of a thing. So when you want to apply anything, what you know, to the other part of it, then you should have that kind. It's called the systems thinking. So you're supposed to have a systems thinking, so that anything could be connected to anything. So keep this in mind. It may not be just 1 credit course according to me. If somebody you feel that you would like to work with sir, okay, on a project, the internships, I think they'll all be very happy to do it. So keep this in mind. I don't know how many would like to take it, but still I'm giving an option. And if nobody accepts in the college, come back to me, I'll give permission. Okay, so that's the way the whole world runs today, because the best engineering things are not been done by engineers. It's done by non-engineers actually. So there is no pride as such for an engineer. Because if you take Leaning Tower of Pisa, the original design of that was done by historian, not an architect or a civil engineer. So like that, the marvels of the world will be like that, because it is typically critical thinking, problem solving, systems thinking. If you have these 3 approaches, then I'm sure you can connect the dots. Today, technology is available just like that. I'm sure all of you can get all the data, whatever he has explained also in ChatGPT. It is available. But your job is how to connect these dots. For what kind of an application, what has to be done. So I request all of you to please be careful and try to select. Don't think just as only a 1 credit course for sports. Okay, I will not go into too much of details. I think you would have explained. So the variable, you can try to look into it. Whatever is the sports and games you are interested, you can take all those things and see what are the kinds of sensors. I think somebody should take an exercise of finding out how many sensors are there. There are thousands of sensors available already. Do you know what kind of a sensor, what it does? You can, any problem is there for you? If problem is there, you can go out. So you can imagine what are the kinds of sports or games you are looking into, and what kind of a things would be needed. When you are doing all these things, my sincere request is, I'm sure some of you may be representing the college here, I don't know. So if you're representing, you will know in a specific space. In fact, sports engineering, experiential learning, we have done so many things, and papers are also published through just this kind of a 1 credit course. We have published a lot of papers also in the college. I don't know Vishwanatha is taking care of that for your batch or not. Okay, because you people feel paper writing is a burden, why you have to write and things of that sort, but you don't know the value of writing a paper. If you start understanding that, I have seen many good people, like say in antenna systems in anechoic chamber, if 2 of our people have written a good paper, they have got selected into Purdue University for MS program with free ship. You don't have to pay the fees at all. That's the value of the papers in the universities. But you people don't realize, because 90% follow the mass mentality. You don't even understand the value of a paper. So if somebody who realizes the value of a paper, you can go into the higher plane of reference very easily. I had a second year student in electronics long time back. I think even today I remember that person. He is a person who had written a paper in IEEE transactions. People with 10 to 20 years experience cannot write a paper in that IEEE transaction. A second year student had written a paper. You know the kind of opportunities he got? You got into MIT, Stanford. Just one paper in IEEE transaction will make your whole life different, because if you want to get published a paper in IEEE transaction, it should be really innovative. Simply your ChatGPT copy and paste will not work there. Fine, but you're all caught up with lot of these kinds of getting data from the sources. That is okay. Run-of-the-mill kind of things, you can always do it. Submitting your assignment, copying from there. These are the things which is okay. But if you want to be really different from others, which everybody follows this path and you want to follow a different path, it looks to be a little bit difficult in the beginning. But once you go and reach certain place, I don't think there is anybody in that. It's called the Blue Ocean Strategy. There's a beautiful book on Blue Ocean Strategy. You can read it. They say that you move beyond competition. Today, if you take Apple phone, they're 10 years ahead of in technology. Nobody can even beat them in next 1 decade. So can you think on those lines? This could be taught only by not even 0.1% of the students, let me tell you. All 99% is only mass. You have all come here today because he has told assignment, marks, credit. Then only, that's why we have come. Otherwise, you would not have come here, I'm sure. So please come out of that mentality, because at early age, a lot of that aspiration is there. But with that aspiration, if you don't try to work, it's going to become very difficult. Fine. So you can decide on what all the things which you want to do. So you can also look into what all the output improvements you can make with all those things. I'm sure sir has explained many of these sensors now. What all the sensors which are available. So now you can look into the sports. You can take only one sports or game. Do all the total analysis. Meet the people in that particular area. I don't know if somebody can get a chance of meeting Messi in a football. You can make a good study. He's number 1 in the world now. All the combinations of football, I think he'll be knowing. Nobody else will be knowing about it. So you don't know. You don't know. There is something called the game theory. I don't know how many of you heard what is that called, a Shapley value. Anybody has heard a word called Shapley value? You don't know. So please read some Nobel laureates works, you'll come to know. Shapley value is that. Shapley is an economist, and he got Nobel Prize for the Shapley value in 1960s. So he says that theoretically, you can meet any person on this earth with a maximum of 7 connections. You can meet, if you want to meet anybody, you would like to, Obama you want to meet, you can have this called as a dominant nodes in game theory. If you can have a dominant node, you can meet anybody. So that's called as a Shapley value. Any of the connections in this earth could be done with theoretically 7. It may go up to 8 or 9 sometimes. You know who are the people who use this for the first time? When they wanted to hit Bin Laden, okay, they used it, not Bin Laden. Bin Laden is a separate theory. So it's called as unstructured data. So when they wanted the Twin Tower, they've used this principle. They found out 7 countries, the dominant nodes. They've all worked for 4 years to hit the Twin Tower. You go back and look into there's a beautiful paper on how they have done it. One of the best scientific journal papers it has. Fine. So you have to think a little bit differently, that's all. Because today, if you think alone, you are not needed, because anyway, all your AI tools are doing it. 80% of the operational jobs today would be done by AI. You are not all needed, let me tell you. Not needed. Already companies are feeling that. So then what is your difference? You want to work. So that is where the way you think, the out of the box, they say, no? So that out of the box thinking, if you can do it. So this is one such here. I'm sure that the sports is getting a lot of momentum in India now. We are still in the introduction stage of all these sports actually. Maybe you can take next 50 years, because you go back to China and check it. The investment they make, the technology they have, you can't beat any of them in the gymnastics and all those areas, right? So that if you can take it as a profession, then it will be very good. So you can try to map what all the games you have, what all things you would like to have, And I'm sure that nowadays the youngsters who are all there, they don't have a stamina, they don't have a strength. One match they'll play, 3 matches they will sit. So it's all because you have not been physically strength, mentally also no strength. Both are not there, but you want to achieve things which is not possible, either in sports or any other field. Resilience would be needed. So you have seen, no? I think any sports and games, you see all these kinds of problems are there. So now how to, because they want to still play, so then you'll have physiotherapists, everybody keep on telling all these people. So you can just look into it, what are the kinds of sensor, where they use it. Today clocks have come. You have a health sensors, correct? Your Apple phone, if you take how many steps you walked, all those things already it is giving to you. Fine. So like that, people have tried to use all these kinds of sensors for different games. It will be different points of contact, different kinds of biomechanism. You are going to face it. Let me look into it. There are some platforms. You can go back to these platforms and check it. What all things which are available, what is the primary use of this, then how the sensors are integrated, and application you can do it. AI tools, we know better than you. So because I AI tool better than you, because I done a fundamental study of all this. What I use Copilot, I use Claude. These two generally I use it. I have it in my mobile only. Every day I use it. But I know what to look for in that. You call it as a what? Separate subject called prompt engineering, correct? So it's just how to ask question. So we do all these things because I done a fundamental study. My area of work could be lean manufacturing, any kind of modeling, supply chain and logistics in these areas, or ergonomics. In these areas, I've done a thorough study. I've studied some good books, the best books of the world, whatever is available. I've done all these things for first 20 years. Now what happens is, I know what to ask in a ChatGPT, and it is giving correctly or not also I can find out, because I've done a fundamental study. This study is not being done. You are straight away jumping into AI tools. So now what's happening is your study is discrete in nature, it's not continuous in nature. That is why you are even the critical thinking, the continuity in the thinking will not be there. You'll jump into solution mode if some problem is given. So it will be discrete in nature. Maybe sometimes you are smart, it can escape. You can fool some people, sometimes not all the people all the time. When you go to the workplace, if you've not done a fundamental study of any of these, your field, whatever you're going to select, then how much ever AI tool is there, you're all going to face problem. I'll give an example. My daughter works in Cisco, she's in the AI department. So she tells me that they have one project manager is there, and there are 10 people working under him, and all the 10 people, problem is given by the customer. He distributes the problem to these 10 people. And then what is happening is, he gives individually, these individuals go to your cloud or somewhere, find out the program, they run the program. Every 10 of them are running the program. Programs are available already. They are taking it and running it. Okay, you are also doing same thing every day. So then it is getting integrated. So he runs the program, this also running beautifully. And then he supplies to this customer. He also is running beautifully. That means AI is good, is not bad. So now the problem is like this. It runs for some time, and then the customer has some problem or he wants to add something extra to that. It comes back. Now this fellow project manager doesn't know where the error has happened, because they copied and pasted the programs. So each person doesn't know which program where the error has happened, because many people don't know how to read a program also. This is the status. So believing on AI is good, but you do that fundamental study first, then use it. You'll appreciate. That's why I'm telling you, I appreciate all these tools much better than you, because we have done these kind of. So don't miss on that. That's why they say creativity, cognitive abilities, critical thinking. All these things doesn't come through your AI tool. It comes only through your thinking. Do that, and then go for any tool you want. You'll be more successful actually. Without doing that, if you go, 4,000 people removed, 3,000 people removed is only because of this factor actually. So please, this is a warning I would like to give, that all of you please go through fundamental study. Take one good book. We are given 5-6 reference books for each subject. Don't worry about that. Take one best book in the subject. Read thoroughly. Then use any AI tool you want, it doesn't matter. because you would have understood the fundamentals correctly. Fine. So please don't miss on that part, because if you miss on that part, you're all going to face problem after some time. So these are some of the applications. Then I will not go into. So if somebody is really interested in going to neural networks and regression models, it's already available. The whole lot of things could be done. Then so this is the Biomechanical platform flows, a pictorial representation. Everybody wants to perform better, correct? So I think that's where all these tools are helpful actually. It is going to give what cannot be measured cannot be improved. We're all very happy until you go to the doctor. When doctor starts giving the measurements, then you start getting scared. Heartbeat is not right, liver is not functioning correctly. Until that you feel you are the best person on the earth. Because you are making some subjective judgments and leading your life. But when you go to the doctor, he will tell all the kinds of problems. So what cannot be measured cannot be improved. So even the athletes are like that. If something could be measured, they know how to improve upon that. If you cannot measure, you cannot improve upon that. It applies to any kind of thing. More so in the sports, because all these sports, if you take into it, no, it's all the things happen just in fraction of seconds. That's all. A fall in a bathroom for an elder person happens just within 1 minute. That's all. Afterwards, you know, if some aged people are there in your house, how much people have to suffer. So like that. So this all happens in fractions of a second. So that's why they want to be very careful. Means it is better you know it before. Muscle tear. If somebody has experienced, I had a 3 months muscle tear actually. Horrible. It is very small one. You cannot even understand how my muscle tear is most painless. In fact, bone is okay still. Muscle tear is more dangerous. You will not even feel it if you are not. So your AI tool cannot feel it. No, anyway, it can give the things, but it cannot feel it. So that's how everybody, if they want to perform better, all these things before you'll get a lot of kind of advantages. Then you can try to do it. So I think he has explained a lot of things. I was just looking at it today. People sensor, they will say. So what is the material of a sensor? What's the specification? People don't know this. You all talk very, very high languages. But if you go back to the basics, you'll not know what is the unit of a pressure. If I ask, suddenly many people may not know. If I keep some 10 materials, how many of you can identify the material itself? Starting from cast iron to mild steel to carbon steel to bronze to nanomaterial to the composite material. If I keep line just like that, no, how many of you can identify? That is your own ability. Fine. So in that way, the specifications of all these things plays very, very important role. This is where research plays an important role. For particular thing, some specification is given. Let us say EMG. So 0 to 10 millivolts is given. For your situation, measuring a EMG, I mean a little bit less voltage or more voltage. This may not do that work at all. So now what happens? Now we have a point of research. Research starts like that only. If you don't know these specifications correctly, I don't think anybody can do research. This is fundamentally missing with all your courses. You come back individually, I'll show you how poor you are in units and measurements. 99% of the people I checked, you're all very poor. You have studied in PUC units and measurement chapter, first PUC, but first PUC is forgotten anyway. You are more bothered about second PUC. But units and measurement is now we have come to the school only. It has come to 9th and 10th. But if I ask what is unit of an impulse, people don't know. If I suddenly ask you what is a nanosecond, what is a nanometer, many people can't tell. Then you will search for your chat GPTs. So please, there are fundamental things you cannot do mistakes. So more so here when you are doing an application of all those things. See, today people don't know the specifications of a cameras. We have started a lab called Video Surveillance Center of Excellence. So many types of cameras are available. How do you go and ask? You go and buy a cloth, no? You have some specifications to ask, no? Similarly, ask for a camera. I want to put 250 cameras in my college. What kind of camera? What specification? How do you know about these specifications? There is no course on all these things actually as of now. We have developed a skill lab actually. We have 10 experiments we have designed just to find out the specifications of a camera. It's a huge one actually. It's not so easy as you think, because it will be used under different circumstances. So like that. So I out of all these things, no, I'm interested as an engineer. I want these two things to be learned. These two columns are very important. In all the other three things, it's okay, but these two engineers are very poor. Actually, you are supposed to be strong here. You are poor in these two columns only. You think you take it for granted, actually. Fine. So please don't forget on that. That's what even industry tell us, that you are very poor in fundamentals. Fundamentals are basically these things only they are expecting you. So don't miss on that. Don't miss on that. You are all intelligent in some areas. Please try to maintain that. What you are not intelligent at, you have to supposed to be learned through this. Okay. This is another thing which you can look into. There are some experiments people do. You can also look into that. So now, if somebody is interested in the research in these areas, huge research is required in all these areas. So can you look into these research? You can go back to any of these things. I'll leave all these slides if somebody is interested. And you can also go to these universities where they're doing the research works. I don't know what interests you in this in research. You can try to look into it actually. Look into what is your interest area and then try to map it and start doing. These are all the research domains. Since it's open-ended questions actually. Many things have not been answered. So you can try to look into this and you can try to create this as a profession. So there is an interdisciplinary connection. I think he was showing some videos actually. It has biomedical engineering, it has computer. Any problem? Last but you all, when joining, you'll claim, no, I want only computers. Tell me, computer science is a super layer. Below that, there are a lot of domain things. If you don't know that, just computer layer cannot do anything. Domain becomes today the biggest problem in Bengaluru is that domain knowledge is very poor. You say a computer science engineer, but you want to do for a healthcare sector, but you don't know how a healthcare sector operates. You don't know how a automobile company operates. You don't know how a semiconductor company operates. But what software you are going to develop? If you develop a software, it will be at superficial level, that's all. Nobody will use it. So you cultivate that habit of interdisciplinary nature in you. You can be, it's called as a Intel's T model. Okay, Intel has got T model. T, vertical line is depth, horizontal line is spread. So if you have to balance T, no, it's very difficult. You cannot have too much of vertical line or less of horizontal line, or more of horizontal line, less. It doesn't look nice. So balancing T model up to 1990 was very, very important. That was when only functionalities were there. Interdisciplinary nature was not much. Then in 2000 came pi model. So pi model is, you are supposed to be good in two functional areas and you should know how to integrate that. And develop a managerial abilities is the horizontal line by integrating. Maybe one could be on the robotic technology, other could be on cloud technology. How can you integrate these two? So that's what in 2000 they were talking about. Fine. I don't think even today we have achieved that. First of all, first T itself we are not achieved. Forget about second T. Pi model. You know, the model which is available today in the market is called as a Coombe model. You are supposed to be expert in so many domain knowledges and then you are supposed to integrate. That is what is expected. As soon as jump, first day you go to the company, they are expecting you to do that. Are you really prepared for these things? I don't know. I don't know. Really prepared for that or not, because your IPR, you study for one day. Environmental science, you don't even study and write the exam. You are all at that level now actually. But everything is linked actually. When we are formulating the syllabus, we are looking into a lot of interdisciplinarity, but you can't even perceive now when we say something. Just go to the company, within 6 months you will try to perceive what has been studied, what you are not studied correctly, where you are going to face a problem. So when you are here, 4 years is a beautiful period. Try to get involved in a lot of cross-functional things actually, because that is what people are looking for today, because the core things are already available. It's like a plug and play. During my time, if I want to operate a VCR, so many switches used to be there. That was very difficult to operate a VCR. Today, just one click of a button, you're operating all your, could be internet banking, your GPS, everything, click of a button you are doing. So technology is very simple today actually. But if you want to develop a new technology, a background of what it happens, fundamentals are needed, applications are to be known, and you should be very thorough in the linking the things. So don't try to forget that. So you can see, if you take the interdisciplinary connection in sports, which is there, very huge it is, very huge. Ethics part of it, very important. Ethics, not only data ethics, it's personal ethics also, no? Many people have been removed because of the drugs and things of that sort. It's a personal ethics part of it actually. Right? So all these things have to be integrated when you're trying to do things. So I think this is my last slide. So you can look into the research roadmap, whichever branch of engineering you belong to. You can have I think this slide is very important for me, at least some 5 to 10 people in this room. Up to your final year, you can do projects in this area, you will have a lot of scope. You bring any kind of a combination, I'll give you permission. You have a computer science engineer, you have an electronics engineer, you have a mechanical engineer, bring, I can fit somewhere here. I don't know how many of you looked into this digital twin. This is going to redefine whole lot of things what we are doing actually. Digital twin is going to redefine. I went to Germany, we have a collaboration with the university. So they have taken 25 crores from the government and they set up a huge digital twin in the AR, VR and the MR lab. And you know, whole of the oldest church of Augsburg, he has done a twinning of that. Just I can, sitting in one place in that place, wherever I created the MR environment, mixed reality environment, I can see the church by operating with a remote. So in every area, because how a nuclear fission happens, I cannot see that. If you see a nuclear power plant, you cannot even go near the nuclear reactor at all. What happens inside? I can create a digital twin. Fine. Then cockpit of an aircraft. I want to give a training. I can create a digital twin. Aerospace engine, how it operates inside. Very difficult to know. I'd been to this San Jose Apple experience room. Beautiful. If you just wear Apple lens, I have seen full football match. It was so real. And I have seen a space station. I was thinking that I'm just sitting there in the space station. That's all. That's the way digital twin effect would be there. And now, even in India, I think government is spending a lot of money on all these things. Heritage of the new buildings, heritage of the buildings like Bengaluru, Halebeedu, for tourism purpose. Wherever that, in fact, companies wants to cut the training cost. I want to train a welder. They have a digital twinning of that. Training is given instead of 1 month, training can be given in 1 week. So please learn, irrespective of the branch of engineering, please learn many of these important things. Don't think many things are a computer science subject here. Fine. You can also make a computer science student a friend with you. He can help you in a lot of other things. You do your part of domain. It is possible today. Okay. So I came here just to give an outline of all those things. Sports and games is going to take a very front seat in our country in next 25 years. And the kind of technology people are going to use, it will go to the remote areas. It will go to the rural areas also in future. So it's a huge feature is there. And it's a profession today. Don't think it's a secondary or a hobby kind of a thing. It's a profession today. Either you want to go for job. Analytics is a huge area in sports. And you know, no? You see the things say whether the ball is out or not. So much perfections already have come. So analytics, over and above, can I use AI over that? That is what people are looking for in any of these analytics. So there is a huge potential for your generation. I request all of you to please set your path. Don't wait for 6th semester placement. You set your path, you can go in that path. How much ever tough that path it looks to be, afterwards it looks to be very easy for you. And there are some areas, there are no people at all, there's no competition at all. Don't worry, don't go to the places where they ask only Python programming. Okay, there are millions and millions of people. Anybody knows Golang language? Anybody knows microwaves? Anybody knows analog communication? Thousands of jobs are available in analog. Apple itself needs 10,000 people. Everybody talks about digital communication only. If you want to do analog, people don't want to take because a lot of mathematics is there in that. You don't want to do it, but 10,000 jobs in the world is there in analog, in Apple alone. So that's why I told this path looks to be a little bit difficult, but once you go, whether recession is there, AI has come, nobody is going to remove you. So please follow that path for your generation, particularly. That is very important according to me. Okay. So let me stop here. So I wanted to just connect the dots and make your mind alert. That's all. I would not have told anything other than I think he has gone into detail. He has been doing a lot of good research work in that area. Maybe if anybody wants to get connected through that, I think he will be happy to do it. We are all a part of a sports engineering association actually. So I'm also there. He's also a member. Vishwanatha is a member. It is started by actually Chandrasekhar is there. Reddy is a lot of people are there. This sports engineering association we started actually with BITS Pilani actually, and we have a lot of colleges in the country. So as a part of that, we have organized this, and this will be, in fact, we also want to make 18 credits of a minors in sports engineering. Maybe very shortly we may do it. By next year we may do that, because it's such a huge area of a profession that if somebody would like to go into that area, you can do the minors and then go into that pattern. Okay. So with this, let me stop. Thank you very much.
Thank you very much, sir, for your motivating and insightful words. I think our students are enlightened with your words. Sir, 1 minute. Now it's time to honor our today's guest, Shri K.P. Venkatesh. Now I request our beloved Principal Dr. KN Subramanya sir to kindly honor our distinguished speaker with a memento as a token of our gratitude and respect. Give him a big round of applause. After this program, computer science students, please go to the yoga hall and then you can verify your marks and then you can sign it. Remaining people, please be seated. Those who have completed, you can move out. Now, I invite Srimati Meenaxi Mutalik, Desai, Assistant Director of Physical Education, to propose the vote of thanks.
Good afternoon, dignitaries. On behalf of Sports Department, Physical Education and Sports, I extend my heartfelt gratitude to the Sports Engineering Association for organizing this wonderful event. I sincerely thank speakers Dr. K.P. Venkatesh for his valued words. I also express my sincere gratitude to beloved Principal Dr. Subramanya sir and all the members of Sports Engineering Association. I would like to also to thank all the faculty members, the participants who have joined us online for their valuable presence and support. Thank you very much. On behalf of the entire team RV College of Engineering, I once again express our sincere appreciation to everyone who has contributed to the success of this event. It has been broad privilege, pleasure to have you with us. I special thanks Udat team. Thank you so much. Thank you, students.
Thank you, madam. Thank you all for your gracious presence and active participation. We sincerely thank our respected principal. We went for an event and he came on time and then delivered address. And our distinguished speaker, Dr. K.P. Venkatesh, all faculty members, students and guests for making this program a grand success. Have a wonderful day. I request all of you to join for a group photos. Sure. Those who are sitting beside, please come and sit beside.